On January 14, 2004, President Bush announced the new vision for space exploration, redirecting us to return to the moon by 2020, just like we did in the Apollo program.
What we're considering now for the new moon program is to actually build lunar bases that have multiple missions in mind, multiple crews that will visit there. And so we can see lunar exploration going on for 15, 20, 25 years into the future.
What is important to understand, though, is that the moon is not the only objective in itself, that the moon will serve as a stepping stone toward Mars. We are starting to see space exploration not as a set of isolated missions, but as an entire campaign.
Turns out that if you want to make extended stays, logistics ends up being an extremely important aspect of that in terms of efficiency and in terms of safety and in terms of scientific return. That's something that we found out through continued operation with the space station.
There was an incident a couple of years ago where lithium hydroxide containers couldn't be found for several days. While these lithium hydroxide containers were misplaced, it was impossible to do extravehicular activities. And this brings us really to the key point of this research, to develop a framework for modeling space exploration as an interplanetary supply chain. Now, the implementation of that framework is done in a software environment that we call SpaceNet. SpaceNet is a discrete event simulation and optimization tool that allows us to model the flow of vehicles, crew, and cargo from the Earth to exploration destinations in space, either in orbit or on planetary surfaces.
When you're looking at planning logistically for any supply chain, there are sort of three main options you have. You have what you call carry-along, which is what they did in the 60s with Apollo, and that's you take everything with you. Your second major option is called scheduled resupply, and that is going into space and having planned resupplied missions to your location. The third major logistics paradigm is what you call pre-positioning, and that is you know where you're going to be, you know you're going to have such and such demand, and so you send the materials you need ahead of time, and so it's there waiting for you.
The way that SpaceNet is most effectively used is by generating a nominal plan that would typically consist of a set of missions over time. For example, the build-up and sustainment of a lunar outpost. In such a campaign, you would have a mix of uncrewed cargo delivery flights as well as crewed flights. And you could model the sequence of these flights, the cargo that each of them would carry, and how this cargo would be consumed, used, and built up at different nodes in the system.
The second major framework that we use is something called Measures of Effectiveness, or MOEs, and these are 8 parameters that tell you how good, how effective, how expensive, how risky your mission was.
So in the summer of 2005, we went to Devon Island in the high Arctic, and the purpose of that trip was to test logistics technologies and strategies and collect information on what it means to do logistics in remote locations, and specifically at exploration bases.
What we learned on Devon Island helped us to obtain data, calibrate our models, understanding the differences between Earth, Moon, and Mars exploration.
The second purpose has more to do with technology. We wanted to test RFID, technology radio frequency identification.
An interesting paradigm for the challenge that the crew faces is they're living inside a laboratory, and that laboratory is stocked with a variety of items. And unfortunately, if we lose track of those items, we can't just call up and have another one sent to show up the next day on the FedEx truck.
The idea would be to develop specific customized technology that could be used to sense when different contents went into the base, where they were on the base. Basically make it much easier for astronauts to do micro-logistics.
At the heart of Ramses is a container that has the ability to interrogate its own contents.
All of the items that we place in the container have tags on them, and each tag has an individual unique ID code. Inside the walls of the container are antennas that read those tags.
And will then transfer this information wirelessly to a computer and a database that automatically keeps track of all the transactions in the system. The crew could query the real-time state of the system through the internet.
Ramses is one way to assist the crew in being as productive as they possibly can, and essentially removing the question of where is this item from the equation.
Any little thing you can do to make sure your mission has a higher chance of being more successful, anything you can do to capture all the unforeseen circumstances and plan the best you can for them is very valuable and a worthwhile endeavor.
One of the most exciting things that will occur in this century is the return of humans to the moon. It is a stepping stone toward humans truly being able to explore beyond low Earth orbit. I'm a believer that it's the destiny of humanity and our civilization to ultimately settle our solar system and maybe beyond.
The exploration of our universe broadens our awareness of what it means to be on the Earth, what it means to be human. I think that's an adventure. I think that's an exciting thing to be a part of.